Sorry about the tardiness.
Oh, looks like we got Wade.
Okay.
So I clicked show my screen.
Okay, I think we're starting.
What do you see? Do you see my screen?
I do. I see your screen and I see you. And I understand the attendees can see us and hear us. So we'll go ahead and get started. Thank you, everybody. This is my first time using GoToWebinar as a host, so appreciate your patience with with us as we try and get settled here. Hello, good afternoon, or good morning to you. My name is Paula Gonzalez. I am the Senior Manager of Membership Growth for AAPA. Welcome to AAPA's first webinar of 2021. Throughout the COVID-19 pandemic, I know we are all doing the best that we can to stay connected to each other, to our colleagues, and to our peers, and to stay informed and up to date on what is going on in our industry. I know many of us would probably rather be doing this in person by attending conferences and seminars and trade shows. But since we can't unfortunately meet face-to-face just yet, AAPA has been working to bring you content, news, information, education, and opportunities to connect throughout the year through virtual programs such as this one. We have lots of exciting programs planned for 2021. So if you're keen to learn about additional opportunities to connect and learn, please hang around for just a few minutes following the conclusion of the presentation today, and I will be happy to share with you some additional ways that you can engage, learn, and network in 2021 through AAPA. Now we'll go ahead and get started. I am pleased to welcome one of our newer members and the presenters of today's webinar, Young & Associates. Young & Associates and YA Engineering Services are affiliated companies that provide services on existing buildings and structures. And they will be presenting some case studies from past marine and port type projects that they have worked on, providing a general overview of the types of specialized services that they provide. Now I would like to turn it over to Amber Herlocker of Young & Associates to introduce our speakers. Amber, take it away.
Thank you, Paula, and thank you everyone for joining us today. I am Amber Herlocker, the Regional Business Development Executive for Young & Associates and YES. In a moment, I'll turn the presentation over to Rich and Wade, but I did want to give a couple housekeeping items. The webinar is in listen-only mode, but please feel free to ask questions. Just utilize your chat box located in the panel on the right side of your screen. Paul and I will be monitoring this throughout the presentation, and we'll reserve time at the end of the presentation for questions. This presentation will cover Young & Associates and YE Engineering Services involvement in evaluating a partially collapsed seawall in remote Alaska, including evaluation of project cost, scope, repair, and causation. Young & Associates and YA Engineering Services are affiliated but separate entities that provide consulting services on existing buildings and structures. Young & Associates has over 230 offices across the United States, overseen by 6 regional partners and offices in UK and LATAM. YES is founded in 2017, provides a network of engineers that can handle any type of engineering services, including but not limited to performing structural investigations, repair designs, litigation support, and code upgrade analysis. Our company strives on the values of knowledge, integrity, and professionalism, whether we're in the field, boardroom, or courtroom. Our presenters today are Wade Bushman, CEO of Young & Associates, and Rich Deflis, PE and President of YA Engineering Services. And I'll allow these guys to introduce themselves and begin the presentation. Thank you again for your time today.
Thank you, Amber. Rich, do you have the presentation up here?
I believe we're presenting. Is it visible?
I'm not sure if the slide is full, but it might be just on my end.
You need to put it in presentation mode.
Yeah.
You just might need to switch your screens, Rich. I think it's showing your opposite screen because we see your speaker notes. That's what we see.
Rich, I think it's that upper right present mode.
Well, I can just change. How about that?
There you go.
Well, where there's a will. All right.
All right. Well, hello, everyone. I'll kick it off. My name is, and thank you, Amber and Paula, for the introductions there. My name is Wade Bushman. I'm CEO with Young & Associates, and on behalf of the companies, we want to thank the AAPA for your time today and all its members. We're excited to meet with you today. As Paula mentioned, you know, we all wish we could probably doing this in person, but this is just the new norm that we all live in today. And again, thanks for your time, and look forward to sharing this with you. So I am, again, CEO of Young & Associates, live in Nashville, Tennessee. And of course, we got Amber, and she's introduced herself. Rich Detlefs is PE with YAES, and then plays an intricate role on a senior management level with our company as well on the building consulting side. The next one there, please, Rich. So I'd like to share a little bit just about our company, introduce some of our services, and then turn it over to Rich here for the actual presentation. Young & Associates was founded over 23 years ago. We have a national footprint, including Hawaii, Latin America, Alaska, and then we've got presence over in the UK as well. Our footprint, this gives a pretty good example and snapshot of what we call YA jobs, and then our consultants. We strategically place our consultants in every major market. You can see we have, you know, heavy presence on essentially every coast within the continental United States, and of course in Alaska and in Hawaii, and that is to reduce, to have local presence there for our experts at your disposal in general. Our company, again, started more from a regional standpoint after the Northridge earthquakes in California. Ray and Linda Young are owners, and their core values have always been knowledge, integrity, and professionalism. And as we've grown to, you know, a 20+ consultants over the past, you know, handful of years, we've grown, you know, near 300, especially through the CAT activities as those services are needed. But these are values that we live by, and our work product represents. So bread and butter for us is property damage consulting. And so we, most of our background's on the consulting side, and I'll let Rich really go into more detail on the engineering side, is building damage consulting and cost estimating related to either replacement or repair needs, either when there's a loss or you know, a project management type need. Just to run around this circle a little bit here, I don't want to take too much time away from the presentation. We do have an environmental division, and so when those you know, needs arise, we have expertise that cover those. Dispute resolution with legal is relevant when two parties need to come together either through arbitration or legal standpoint, and so we provide expert witness services as needed. Contents evaluation, critical path with scheduling. We have master schedulers that can put together accurate timelines on what either repairs or new construction or capital improvement, what the timelines actually represent. Got a surety division, project control and clerking. That's more on-site activities for quality control and several other, you know, cost control measures. And then construction defect, and then again, I'll let Rich really kind of jump into the engineering services as we move through this here. really excited about rolling out a big investment for us is a new website. Again, we're spread out strategically throughout the country. Submit an assignment through our website. We've got automatic location detection tools, and then an advanced directory for filtering on, capacity and, around which is the right consultant to meet whatever needs are out there. So Rich, I'm going to hand this over to you if that's okay, and let you start going maybe through an introduction on the YES side and then into the presentation.
Thanks, Wade. Yeah, I'm going to do something real quick here. I finally figured out how to move this to my other screen. So I'm going to switch screens and then we'll be off. Boom. Does that look good? Can people see that?
I can, yes.
Okay. One more thing I got to do here. Pull that down. All right. I think I'm ready to go. Hi, everyone. I've got my own picture up there. My name is Rich Detlefs, and I am happy to be here today. Happy for you to, pleased that you would invite us to join your meeting. I'd like to give a brief description of myself and our engineering services company, and then get into a few project examples today, the type of work that we perform. I happen to be located in Seattle, so you'll notice a distinct Northwest theme to the projects that I'll be presenting today. I'm president of YA Engineering Services. I'm a forensic structural engineer, and I've been practicing for 26 years. I joined YA in 2017 after 22 years at my prior firm. In January 2019, we started YA Engineering Services. Since that time, we've added approximately 20 engineers, architects, and non-destructive testing specialists across the country who specialize in damage and failure analysis, structural analysis and modeling, construction defect investigations, evaluations of earthquake and hurricane damage, non-destructive testing, marine structures, roofing, litigation support, building envelope, mechanical, electrical, and building code reviews. As far as my background, the types of projects and structures and failures that I've worked on over the years is pretty varied, a handful of which I'll be sharing with you today. In the late 90s, I spent a month in South Korea performing non-destructive testing of concrete bridge piers for the South Korean high-speed rail system. I inspected welds in the Los Angeles subway system. I invested a steel oil derrick tower in the oil sand fields of northern Alberta after the tower next to it exploded and melted. I've worked on bridge collapses, a tower crane collapse, parking garage collapses, and a number of other partial building collapses. I've testified in trials, arbitrations, in front of dispute review boards, and I've been deposed more times than I can count. Today I'm going to present 4 case studies of marine and port type structures that I've worked on over the years that is hopefully relevant to this particular audience. I'm going to start with a seawall partial collapse that I investigated in 2008. This was in Homer, Alaska. We were retained to investigate the cause of the partial seawall collapse. Homer is located at the southern tip of the Kenai Peninsula at the mouth of Kachemak Bay, where it meets Cook Inlet. Homer is approximately 123 miles by air southwest of Anchorage. It can also be reached by land, but it's a 221-mile drive that takes about 4.5 hours. For those of you unfamiliar with Homer, it is most famous for the Homer Spit. The Homer Spit is a 4.5-mile long piece of land at the southern tip of the Kenai Peninsula that juts out into Kachemak Bay. The Homer Spit features the longest road into ocean waters in the world, taking approximately 10 to 15 minutes to get to by car. When I was there for this project in 2008, there were people camping on the Spit, and we stayed at a hotel at the end. It was really cool. If you ever get a chance to visit, I think it's, I'd highly recommend it. For the project, we engaged Anchor Environmental to provide coastal engineering analyses. Anchor's study included evaluating tides, wind, and waves, and review of 2 storms in early 2008, one in January and another in March. Winds at the site were found to occur predominantly from the northeast and the southwest. The southwest direction also represented the longest fetch direction at the site, representing approximately 80 miles of open water. Therefore, storms with sustained winds out of the southwest would have had the most impact on the site. This is a view of the wall that we were looking at. The seawall was constructed in 2002 and located just northwest of the spit. So it was only approximately 6 years old at the time that we were investigating. The wall is approximately 1/4 mile long and was constructed with box section fiber reinforced polymer sheet piles that were 18, 20, or 22 feet in depth. Per the design, approximately 10 feet of the sheet piles were buried and approximately 10 feet were exposed. There were horizontal steel whalers at 3 feet and 6 feet down from the top. Putting the highlighter on those. The steel whalers were tied back with rods that were anchored to reinforced concrete blocks. 6x6 timber piles and 4x12 timber lagging comprised the wood facing. The wall was constructed in 20-foot segments with 2-foot by 4-foot steel plates at the joints. Upslope from the seawall were a series of other retaining walls of varying age and construction. On January 26, 2008, a 40-foot section of the wall near the east end collapsed. The breach in the wall was replaced with steel sheet piles prior to our visit. The steel sheet piles actually represented an upgrade over the original structure. In this picture, the rust-colored steel sheet piles represent the 40-foot long section of the collapse that we were investigating, which occurred in January 2008. The 20-foot section of galvanized steel sheet piles to the right represented a prior 20-foot wide breach that occurred a couple years prior. In the photo, you can also see the washout of the hillside that occurred behind the wall when it was breached. In this photo, you can see that there was little in the way of riprap to protect the base of the wall. Prior reports indicated damage occurring to the wall shortly after construction. There were reports in 2002 of surface water from the bluff damaging the wall. And reports in 2003 stated that the wood panels moved up and down with wave action during high tides. The wall generally faced south. We observed heavy scour at the base of the wall at the east end and sand buildup at the base of the wall at the west end. The 2-foot by 4-foot steel plates at the joints were heavily damaged. Some were bent down in half, like the one in the background here. The third one back here is bent over. Others were missing bolts and some plates were completely missing. This is a close-up of the base of the wall near the east end, where approximately 3 feet of scour had occurred. Originally, the soil was in contact with the wood lagging. Approximately 800 feet of the wall had some scour at the base. At this location, the 6x6 timber piles were not even engaged in the soil. The Anchor study revealed that the design should have anticipated scour of up to 2 to 4 feet. There was also ongoing long-term erosion at the site. In fact, a 2004 study revealed that this section of shoreline had an erosion rate of 2.6 feet landward per year. In summary, the coastal engineering study found that the height of the wall was likely adequate, as only extreme height events would result in water overlapping the top of the wall due to tide, wind, and wave. However, the design did not adequately account for scour at the base of the wall and ongoing erosion. In fact, the storms in January and March 2008 only represented storms with a return period of less than 5 years, so not what we would have considered extreme events. We concluded that the wall pile should have been embedded deeper into the soil, and the base of the wall required additional protection from scour, including riprap. In addition, there should have been some measures added to ensure stability and drainage of the landward slopes during heavy rainfall. The next project I'm going to talk about is located in Seattle. It's Pier 69. It's an 87,000 square foot reinforced concrete structure that was constructed on cast in place concrete caissons. It was built in 1931. I first worked on Pier 69 in 1995. The pier had been the subject of evaluations by other firms prior to our involvement, who identified corrosion of reinforcing steel and recommended repairs to address spalled concrete and exposed and corroding reinforcing steel. They also recommended annual inspections of the structure. The structure itself was massive, and it was like a complete maze when you were underneath it. We accessed the underside using a motorized skiff and operator provided by the port. One of the first things we did was paint grid lines on the columns so that we could always identify where we were under the structure. As you can see, when the tide was low, we could maneuver easily under the structure, but we could not get up close to the beams and girders when the tide was low. This was important if we needed to do any hammer sounding of the concrete, which is what we'd use to verify integrity and identify areas that were delaminated. Conversely, as you can see in this picture, if the tide was up, we could barely maneuver under the structure without bumping into beams, especially if there were any waves. This is a fairly typical example of the type of corrosion and spalling occurring at the underside of the beams and girders. The distress was generally confined to an area about 30 to 40 feet from the east, west, and south sides in the tidal splash zones. The concrete in these areas was found to have very high chloride content from contact with seawater. Chlorides make steel susceptible to corrosion. This is another photo showing corrosion and spalling at the underside of the concrete deck at the west end near the seawall. In 1995, our involvement was generally limited to the condition assessment and reviews of prior studies. However, we did retain a contractor to provide a repair estimate. The estimate to repair the entire structure in 1995 was approximately $900,000. In 1998, we were retained to analyze the structure and develop conceptual repair drawings. Our analysis revealed a number of interesting finds. First, approximately half of the 87,000 square foot structure was designed to support 600 PSF live load. The other half of the structure was designed to support 1,000 PSF live load. The current loading, which was office space, only required 100 PSF live load. The deep girders were primarily loaded in shear and were adequate for current loading without reinforcing. The structure had so much excess capacity that it could sustain the loss of concrete in the bottom layer of reinforcing steel in the beams and still support the required dead and live loads. Given the results of our analysis, we did not recommend wholesale repairs throughout the structure. However, we did recommend trial repairs to determine their efficacy in this environment, and also so that more accurate pricing of the repairs could be determined. We also recommended, instead of annual inspections, inspecting the structure every 5 years. The port agreed with our recommendations, and we re-inspected the pier at about 5-year intervals thereafter, performing follow-up condition surveys in 2006, 2011, and 2016. During each survey, we would photograph every beam, pier, and girder from multiple angles and would provide the entire photographic library to the port so that at each survey, if there was an area that appeared to be worsening, we could readily go back to the prior surveys and determine in that area if that area was in fact worsening. This photo shows the trial repairs that we installed in 1998. During each of the follow-up condition surveys, we would hammer sound the trial repairs to determine if any delaminations were occurring. As of 2016, the repairs were holding up really well. This is another port project I looked at in 2008. This is a grain facility that receives and stores grain from trucks and railroads, storing the grain in silos, then using a conveyor to transport the grain out to spouts that distribute the grain to ships holds. The facility has 5 towers, each approximately 190 feet tall, and each tower has a spout. In this photo, the arrow to the right indicates one of the 5 spouts used to distribute the grain to the ship's holds. The spouts are approximately 25 feet long, and each is operated by a series of cables and pulleys to crane it up and out over the ships. The arrow on the left indicates where one of the spouts was missing. This one had fallen off into the hold of a ship, which is why we were engaged. One spout failed in 2006, and another failed in 2007. The facility was constructed in the late 1960s. This is a photo from up under the horizontal shipping gallery, which interconnects the top of the 5 towers. It was determined that the 2006 spout failed as a result of bending fatigue in the pendant pin, which connected at the top of the tower. It was recommended to redesign the pendant connection and retrofit the other 4 spouts with the same connection, so that the pins would no longer be susceptible to this type of fatigue failure. Another part of our engagement was to review the original design and determine what code upgrades, if any, would be required at the facility as part of the repairs. This is the last project I'm going to present today. In 2004, I was engaged to investigate the failure of 3 120-foot tall light poles at a dock in Bristol Bay, Alaska, which is located just outside King Salmon. It's at the mouth of the Naknek River, approximately 290 miles southwest of Anchorage. The 3 light poles at the site were installed in 1995. 2 of the poles were located on this dock. The workers noted that when the wind blew, the poles on the dock swayed excessively, so the 2 poles on the dock were removed. This photo shows the 3rd light pole, which was located next to the dock office and had not been removed prior to our site visit. The 2 poles that were removed were stored on the site, so we were able to inspect them. What we found was that the base of the poles were cracked just above the weld connecting the pole to the base. We worked on this project with Dr. John Fisher, who's a professor at Lehigh University, and literally wrote the book on fatigue analysis in steel. We removed samples of the metal at the crack and sent them to Dr. Fisher, who performed a fractographic examination of the fatigue surfaces. The failure surfaces revealed that the metal failed in fatigue. Since the poles failed after only 8.5 years of service, they were subject to high stress, low cycle fatigue. Static analyses of the poles found that they were overstressed during moderate to high wind loads and reached yield at design level wind. The base of pole weld detail was a category E detail, meaning that the stresses on the connection needed to be limited to very low stress cycles. Our analysis found that only moderate winds would exceed the allowable stresses in the welds. We also found microcracking at the base of the land-based pole, indicating that it too was in early stages of fatigue failure. Our analysis of the original design found that it was insufficient and the pole should have been designed to keep stress levels lower. We recommended replacement of all 3 light poles. That's the end of the examples I was going to present today. So at this time, I would like to invite anybody to ask questions.
Thanks, Rich. Everyone can utilize either the hand raising or you can type questions in the chat box. I know Paula put it out that you can utilize that chat. Rich, can you tell us the footprint of your engineers? I know we established some of the YA folks and their footprint, but can you elaborate on your team and kind of where they're located and licensed?
Sure, yeah, we can. We actually have certificate of authorization in all 50 states and District of Columbia. We have engineers in 10 states. We currently have people in, I'm going off the top of my head, but we have Washington, California, Hawaii, Colorado, Ohio, New York, North Carolina, Tennessee, Texas. So we're working our way across the country. If you know of anybody good, let me know. I'd love to talk to them. But I think that, oh, and I'm sorry, Chicago. I missed Chicago. Two of our people are non-destructive testing specialists, and one of whom is pretty renowned nationwide, if not worldwide. He's got equipment that'll see 6 feet into concrete. He's worked on some pretty fantastic projects all across the country, and we have some, for considering how short of a period we've been in operation, we've really accrued some really great levels of expertise.
Rich, I have a question. Curious as to why every 5 years was safer to inspect the seawall versus a yearly inspection. Why would not a yearly inspection be safer?
Was that regarding Pier 69, which that was not a seawall, that was the underside of the pier?
Yeah, there was no specific indication as to what it just said. They inspect the seawall versus a yearly inspection.
Okay. Yeah, the inspections were not related to a seawall. That was related to Pier 69, because basically the rate of corrosion that we were noticing after 60, 70 years of service really hadn't even brought the structure to the point yet that it was requiring repairs. And what we were able to see was that it wasn't changing much, and it was a pretty slow rate of deterioration, and there was so much excess capacity that it just didn't really need to be looked at every year. And you bring up an interesting question about safety. Safety is an interesting term because everything we do has some form of risk associated to it. And what really comes down to is you weigh relative risk to cost, and so you do a cost benefit risk analysis, and you determine, it'd be safer to look at it once a month. But the reality of it is we didn't really think there was a problem yet at the time, and it just didn't necessitate that level of recurring intervals of inspection.
Another question, what common Port Authority challenges do you see, maybe in the current climate with where we're living in, or maybe due to certain CAT situations? Do you see any challenges forthcoming?
Oh boy. Especially with the current environment with COVID.
Yeah, and I guess Wade, you can pipe in on that too, from the YA side, if there's just any common issues you see with the ports.
Well, I mean, if I had to go off script here and give my own opinions, I think ports deal with product, they deal with people, the mass transit. My own experiences in airports traveling is that there are areas of funneling of flows of people that never anticipated. Social distancing requirements, I think that's a challenge. I think potential there's, if this is going to continue to be an issue moving forward, maybe not this pandemic, maybe the next one, ways to allow people to separate. I know at some airports I go to, they promote social distancing until it gets time to get into a tram, and then everybody gets crammed into a very small area, and it gets really crowded, and you're right up against other people, and you really don't have a way to avoid that, especially when multiple flights come in at the same time. So I would say that's one challenge moving forward. But that's really something that's going to take a lot of long-term planning and design effort to really address, if that's going to be something we address in the future.
Thank you, Rich. Thank you, Wade. I'm going to turn it back over to Paula. As you'll see on the screen, our contact information is there and available. Obviously, you can also access us at youngonline.com or YAES services or yaeservices.com for any of our additional info or services. Thank you again, Paula, for allowing us to present today.
My pleasure, and thank you to you, Amber, and Richard and Wade for your presentations. Very interesting, especially I'm sure given with climate change going on, there are a lot of challenges that our ports are facing. So I'm sure this is very interesting to our audience. So I'm going to go ahead and make myself the presenter again and show a screen because as I promised, we have lots of exciting programs coming up for this year. So I just want to share them with you. Upcoming next month is our Communications Administration and Legal Issues Seminar. That's open for registration, and we've you may have seen some promotions for that. So that'll be an exciting program. And the full schedule for these are on our website. So I encourage you, if you're interested in any of these, to check out our website. Our spring conference will be virtual via our AAPA Anywhere platform, and that'll be March 16th to the 18th. We have our marine terminal management training and commissioner seminars coming up, then followed by our cruise seminar. The cruise industry is very eager to get back to normal, and I know that may feel like it's a long ways away, but our cruise committee has been talking about ways to get back, and so I'm sure that'll be a hot topic for that seminar. Our Port Security Seminar and Expo, we are anticipating having a hybrid event, so a combination of in-person and virtual. That'll be July 13th through the 15th in New York. We are hoping that by September that most people will be vaccinated and will be able to meet in person by that point. So we are very optimistic that we'll be able to have our first really big gathering in Austin from September 26th through the 29th. So I hope to see many of you there. And then our Facilities Engineering Seminar and Expo, which may be of interest to this audience in particular, is scheduled for November 4th through the 2nd in Savannah, Georgia. And then at the end of the year, we'll be concluding with our Executive Management Conference in November in Phoenix. So lots of great things going on. So there are plenty of opportunities to engage. We'll be holding more webinars like this throughout the year as member interest comes up. If you're looking for additional ways to get engaged, if you are an AAPA member and you're not currently participating on a technical committee, I highly encourage you to do so. It's a great way to get to know other people in the industry. I know it's really difficult to do that virtually right now, seminars and conferences, but committees are a good way to do that. You can really get your hands on and help address issues that are important to our industry, help us, as an association, come up with resources and tools that our members in the industry can use to overcome issues and challenges. So these are the technical committees that we have. Any member can participate. You do have to be a member. So if you're not a member and you want to get involved, I encourage you to sign up. So those are just a couple of things, that you can do to get engaged, stay informed, stay connected throughout the year. I really hope that you will participate and that I'll see you in some upcoming programs. Thanks again to our speakers today. That's all I have for you. And thank you for your attention and your participation. It's greatly appreciated. And look forward to seeing you later this year. Have a great rest of your day, folks.
Thanks, everyone.
Thanks, everyone. Thanks, Paula.
Take care. Bye-bye.
Take care.